Hello, welcome to the Chemical Reactions Unit launch video. My name is Zakia. I teach 7th grade science in Chicago, Illinois. To the right, as you guys probably know by now, I travel a lot. To the right in the picture you see me cuddling with two beautiful sweet elephants in Thailand. It was a really great experience. Let's go ahead and get started. The Chemical Reactions unit has 19 lessons. The big unit question is, why is there a mysterious reddish brown substance in the tap water of Westfield? Before we begin, 1. Read and annotate the unit overview, unit at a glance, and standards. 2. Read and annotate the science background knowledge. 3. Print out the unit internalization guide and get a pencil ready. Why does this unit matter? Everything is made of chemicals. Chemical reactions occur when we breathe, eat, or just do nothing. All matter is made of chemicals. Chemistry is the study of everything. Let's go ahead and dive into our chapter overviews. Chapter 1, Properties and Atoms. The Chapter 1 question states, what is the reddish-brown substance in the water? Students are introduced to their role as student chemists. Their job is to investigate a mysterious reddish-brown substance coming out of the water pipes in Westfield, a rural neighborhood that gets its water from a well. As preparation for this task, students watch a brief documentary that introduces them to a practicing chemist who works in water treatment. Students continue to hone their observational skills as they investigate how to develop different substances apart. How to investigate how to tell different substances apart. At the beginning of this lesson, students consider how and why more detailed observations are more useful as scientists than less detailed observations. After students are formally introduced to this idea as the lens through which they will evaluate the quality of evidence in this unit, finally students use this evidence to answer the investigation question, concluding that different substances can be distinguished by their different properties. The purpose of this lesson is to guide students to the idea that different substances have different properties, providing them with opportunities to make and evaluate detailed observations of different substances. In this lesson, students consider why different substances have different properties. They are also introduced to atoms, a tiny building block that make up all matter in the universe. Students watch Everything is Made of Atoms, a video that provides them with initial opportunity to visualize substances at the atomic level. Students then continue their introduction to atoms by reading, annotating, and discussing the article Atomic Zoom In. The purpose of this lesson is to introduce students to the idea that atoms make up all matter. The lesson begins with students revisiting an earlier activity and finding that an atomic model reveals differences between two substances that were once difficult to distinguish based on their properties alone. Students are then introduced to the chemical reaction simulation, exploring the chemical stockroom mode, and gathering evidence that helps them determine whether various models depict the difference or the same substances. The purpose of this lesson is to help students answer the investigation question, establishing that substances have different properties because they are different at the atomic scale. Students then review the observations they made of the pipe, fertilizer, and reddish-brown substance at the beginning of the chapter, re-examining this evidence in light of the key concept that they have learned. Substances have different properties because they are made of different groups of atoms. These groups vary in the type or number of atoms that make up the group. Groups of atoms repeat to make up a substance. Finally, students learn the reddish-brown substance is iron oxide, commonly known as rust. Progress Bill 1. Different substances have different properties. This is because every substance is made of a unique group of certain type and number of atoms. This group repeats the makeup of the substance. The Chapter 1 focus task is where students have the opportunity to explain the brown substance to the people of Westfield, and they have to answer one of the 3 claims. Pause right now to answer the prompt. Here is the exemplar for the Chapter 1 focus task. Moving to Chapter 2, reactions. How did the rust form is the Chapter 2 question. Students begin Chapter 2 by investigating whether or not substances can change into different substances. During this lesson, students gather evidence by observing the chemical reaction that is provided when two substances are mixed together. First, students mix these substances and observe them, recording the change in properties that occurs. The purpose of this lesson is to launch Chapter 2 and establish that substances can change into other substances by undergoing a chemical reaction. Having learned that substances change into different substances during chemical reactions, students investigate how this change actually happens. They use the sim to make detailed observations of how atoms rearrange. This lesson begins with students observing a single substance reaction in the sim, finding that chemical reactions can happen even without mixing two substances together. This finding connects to the claim provided by Dr. Young in Lesson 2.1, two of which dealt with a single substance changing into rust. Having established the plausibility of all Dr. Young's claims, students use the sim to look more closely at what happens during a chemical reaction, observing that the atomic scale difference between when a reaction occurs and when it does not. Using the same atomic tokens from the previous lesson, students eliminate alternate claims that suggest that either the pipes or the fertilizer could have turned into rust, settling on the idea that both substances must have been involved in the chemical reaction that formed the rust. Students reinforce this idea by creating a visual model that explains how the atoms of the pipes and the fertilizer could have rearranged to form rust. Students then complete a critical juncture consisting of 12 multiple choice questions and 2 written response questions. The critical juncture is designed to reveal students' current levels of understanding of the unit's core content, and the results are used to place each student at a particular level on the progress build. This differentiated lesson is designed to provide students with a targeted review and exploration of key concepts and ideas based on results from the formative assessments in the critical juncture. Students are placed in one of 3 groups. Each group is presented with an activity tailored to their current understanding of substances, atoms, and chemical reactions. Progress Build 2. During chemical reactions, atoms that make up the starting substances rearrange to form different groups of atoms that repeat, resulting in different substances. Chapter 2 Focus Task Assessment. Students use the modeling tool on Amplify to model how the iron pipes and fertilizer changed into rust. Pause the video now to complete the Chapter 2 focus task. Here is the exemplar response. Moving to Chapter 3, Accounting for Atoms. The Chapter 3 question states, what was produced during the chemical reaction between the pipes and the fertilizer? As Chapter 3 begins, students are prompted to consider whether or not the chemical reaction between the iron pipes and the fertilizer in Westfield could have produced another substance besides rust. They then read the article, What Happens When Fuels Burn. The purpose of this lesson is to launch students' investigation of how atoms are neither created nor destroyed during a chemical reaction. Students continue to investigate what happens to the atoms of substances as they burn, developing their understanding of what can and cannot occur during chemical reactions. To begin this lesson, students are presented with 3 claims, 2 of which target the alternate conception that atoms can stop existing or be destroyed during a chemical reaction. To investigate these claims, students gather evidence from the sim, observing that chemical reactions of methane and hydrogen with oxygen. The purpose of this lesson is for students to understand that although it may seem as if substances disappear during the chemical reaction, in fact, all the atoms that make up the reactants rearrange to form the products. In this lesson, students consider a puzzling new chemical reaction, one in which atoms appear to change into different types of atoms. This provides an opportunity for students to apply what they have learned about atoms to a new situation. Building on the key concept introduced during the previous lesson, students learned that atoms form the products must have also made up the reactants. To conclude Chapter 3, students apply their understanding of what happens during chemical reactions to identify what other substance, besides rust, was produced by the reaction between the ion pipes and the fertilizer. Chapter 3, Progress Build. During chemical reactions, the ending substances are formed from the same type and number of atoms that made up the starting substances because atoms cannot be created or destroyed. Chapter 3, Focus Task. The students are modeling how to create, the students are not modeling. The students are actually writing an argument for the people of Westfield to explain what was produced during the reaction between the ion pipes and the fertilizer. Pause now to create the Chapter 3 focus task. The exemplar response for the Chapter 3 focus task is below. Moving to Chapter 4, Science Seminar. This is where students have the opportunity to apply what they learned to a new question. Who might have used the unknown substance to steal the diamond? In Chapter 4, students apply what they have learned about properties, substances, atoms, and chemical reactions to help the police investigate a robbery that involved the use of an unknown substance to steal a diamond. On the first day of this 3-day investigation, students must identify the unknown substance. They then use the evidence cards to evaluate various observations of the substance's properties. Once students select the most detailed observation as a strong piece of evidence, students identify the unknown substance as hydrofluoric acid. The criminal used this substance to corrode the glass display case and steal the diamonds. Students are then presented with 3 suspects, each of whom might have had hydrofluoric acid using substances ordered from a chemical supply company. On the second day of this investigation, students determine whether or not any of these suspects could have made hydrofluoric acid using the substances they ordered. Students leverage their knowledge of how atoms rearrange during a chemical reaction to create models that distinguish between suspects who could and could not have made hydrofluoric acid. Chapter 4 task. Students actually write a prompt describing which suspect is most likely to have made the hydrofluoric acid. Pause now to finish the Chapter 4 focus task. Chapter 4 focus task exemplar is seen below. Chapter 4, Lesson 4.4 is the end of unit assessment, where students complete a assessment with 12 multiple choice questions, 2 written response questions, which students analyze and interpret data, evaluate evidence, and construct explanations. The end of unit assessment indicates where students fall along the levels of the progress build. Progress build 1 question. The diagram above shows the repeating groups of atoms that make up 2 samples. Will the properties of the 2 samples likely be the same or different? Examples of properties are smell, color, and the temperature at which a substance melts. Pause now to answer the question. A, the properties will likely be different because the repeating groups of atoms that make up each sample are different. This relates to progress build 1. Different substances have different properties. This is because every substance is made up of a unique group of certain type and number of atoms. This group repeats to make up the substance. Progress build 2. Serena mixed 2 samples together, a gray solid that smells like flowers and a gray solid that smells like bleach. She analyzes the results and found 2 ending substances. One of the ending substances was a white solid. This ending substance is made up of the repeating groups of atoms shown above. Which of the diagrams to the left shows the repeating groups of atoms that make up the samples Serena mixed together? Diagram D. Progress build 2. During chemical reactions, atoms that make up the starting substances rearrange to form different groups of atoms that result in different substances. 3. Tiana is a chemist who is making a chemical to add to swimming pools in order to make the water safer. She mixed 2 solid substances together in a sealed container. The diagram